In this video, I'd like to go over a few examples how we can use proportions to solve some of these problems. So in this example, we're told Sam consumed 40 grams of fat and had a total calorie intake of 1,560 calories. We're told that each fat gram contains approximately 9 calories per gram. We want to know what percent of his calories are from fat. Now, a basic overall picture of what's going on here. Suppose this box represented 1,560 calories. This is the total amount of calories that he had. He consumed a lot, potentially, throughout this day, but only a certain portion of his calories, we don't know what size, is from fat. And we're told specifically that there are 9 calories in each 1 gram of fat. That's what we're told. What we need to determine is what percent of his calories are from this fat. So we need to determine, first of all, well, how many calories were in all of these fat grams. So what I know for sure is that we have 9 calories, and again, I'm going to circle this. We have 9 calories every 1 gram of fat. If I'm using a proportion to solve this problem, we know a proportion is going to be set up if we have 2 equivalent ratios. So if 9 calories are in every 1 gram of fat, we're going to set up an equivalent ratio where we're going to compare, once again, grams of fat and calories. But which one of these pieces of information do we actually know? We're told in this example that Sam consumed 40 grams of fat, so I know that goes right here. We don't know the number of calories in these grams of fat, so here we have our proportion set up. Once again, I started with a ratio that I know to be true, looking at the ratio of calories to grams of fat, and then now I'm considering specifically what about the grams of fat and calories that he consumed in those grams of fat. So to solve this, I will cross multiply, and I will get 9 times 40 equal to 1 times x. 9 times 40 is 360, and 1x is just x. So we have, if we put this back here, what is this 360? Well, our unknown, we were solving for this quantity up here in this ratio, and this is a unit of calories. So this is 360 calories are in 40 grams of fat. Now that doesn't answer every piece of this question here, but that's a good spot to be. We now know, just by consuming this 40 grams of fat, we know how many calories were in those fat grams, and I used the ratio given to me. The second piece of information being asked here is what percent of his calories are from this fat? And now we're going to go back to this picture. We see 1,560 was the full quota here. This was the full amount of calories. But this particular portion here we now can fill in. This is right here. This is 360 calories. So the question is asking, what percent is this? What percent of this 360 calories? So knowing that we can use, once again, we can set up a proportion, percent over 100 equals part over whole, or in this case, part over the total. We don't know the percentage, right? That's what we're looking for. What percent? We don't know. So some part out of 100 will be equal to this ratio of 360 calories over the 1,560 calories. So this is the proportion that I'm looking to solve. So once again, I'm going to cross multiply. 1,560x equals 100 times 360. And if I multiply those and I divide by 1,560, I get approximately, that should be an approximately, 23.1. So we know that approximately 23.1% of his calories were from fat. Now, if you're unsure where to start with these problems, my recommendation would be to start by writing out some ratios that you know to be true. And in this example, I started with 9 calories per 1 gram of fat. That was a ratio that was given to me. Let's look at a few more examples. We have a few more examples on this page. The first one, we're told about a solution, D5W, which is a solution with 5% dextrose and water. In other words, there is a ratio in this solution of 5 grams of sugar for every 100 milliliters. Now, in this course, that is something that you must know. D5W is a solution that has a ratio of 5 grams of sugar for every 100 milliliters of water. Now, we're told an individual is issued, or given in this case, 750 milliliters of this quantity, this D5W. The first question is, how many grams of sugar will be infused? I'm going to stop right there. I'm just going to answer that question. Again, when you see D5W, one of the things that I think of first is that ratio. There are 5 grams for every 100 milliliters. Now, I want to use a proportion here. I want to use proportional reasoning and thinking to solve this problem. The question that is asked of me is, how many grams of sugar will be infused? Well, if I'm going to be setting up a proportion here, I want to compare if I have another ratio of grams to milliliters. And specifically, I want to look for the quantity grams to milliliters of what this individual is receiving. And if I read back here, this individual is given 750 mLs. So that's where this is going to go right here. I'm setting up, again, started with the ratio that I know to be true, and I'm looking for an equivalent ratio of grams to milliliters associated with my patient. I know the patient's going to receive 750 milliliters. I just don't know how many grams that is. And now I have set this problem up where I can cross multiply. 100x equal to 5 times 750. X will equal 37.5. So what is this 37.5? There will be 37.5 grams of sugar consumed. So I'm going to write that out. It never hurts to write out exactly what you found here. I just found that 37.5 grams of sugar will be consumed. That's how much sugar this individual will be infused or will be receiving in this infusion. Now let's move on to the second question. If each gram of sugar contains 4 calories, how many calories will this person receive? Well, once again, I am given a ratio here. Every gram of sugar contains 4 calories. So I'm going to write that out. 1 gram of sugar will contain 4 calories. Now, you could also write this as 4 calories over 1 gram of sugar. Either one would be appropriate here. So if I wanted to set this problem up or solve this question, how many calories will this person receive? Well, which one of these pieces of information, grams of sugar or calories, do I know, and which one am I looking for? If I go back to what I just solved over here, I know how many grams of sugar this individual will be receiving. The grams of sugar is 37.5. I don't know how many calories that is. So this is the proportion that we get. So I'm going to cross multiply. We'll have 37.5 times 4 equal to 1x. And x will equal 150. So we see that this person will be receiving 150 calories. Now, many of you might be looking at this saying, can't I just multiply by 4? If I know the number of grams of sugar is 37.5 and I know each gram contains 4 calories, can't I just multiply by 4? Absolutely. All right. All I'm trying to do here is to set up these proportions in a way, hopefully, that makes a little bit of sense. That these, if I asked you why would you be multiplying by 4 there, this is a way to support your reasoning. Because every gram of sugar contains 4 calories. And we're not consuming 1 gram of sugar, we're consuming 37.5. So we're going to use some proportional reasoning to go through this problem and to determine how many calories there are. In the next example, Normal saline is another solution that you need to know. And this is a solution that has 0.9% per weight per volume of salt in it. This is a solution, and you see that 0.9%, that has 0.9 grams of this salt, NaCl, 0.9 grams in 100 milliliters. That is a ratio that you know to be true for this solution. The question is, how many grams of salt here, NaCl, would be needed to make enough for 1,000 milliliters of this solution? Whatever my solution is, if I'm making 1,000 milliliters of this, it needs to be equivalent to or have the same concentration as 0.9 grams per 100 milliliters. So I know my solution, whatever the number of grams I'm adding to it, if I'm interested in making 1,000 milliliters, needs to reduce to or be equivalent to this ratio in order for it to be normal saline. So I'm going to start with the ratio I know to be true, 0.9 to 100. And now I need to find, in this case, in this particular problem, I'm making 1,000 milliliters, but I don't know how many grams I need. So to solve this, I will cross multiply, and I will get 1,000 times 0.9 equal to 100x. Now when you solve this for x, you should get x is equal to 9. So what do we need here? We need 9 grams of NaCl. The last problem here, we're told that Sam is ordered to receive 500 milliliters of D10W, which is another solution, Q4H. We need to determine how many milligrams of sugar will Sam be given. So, and this is for the entire day. Before I start trying to figure out some calculations here and just trying to jump right to the answer, I'm going to write down some things I know. Some things I know is Sam is ordered to receive 500 milliliters of this solution. So he's receiving 500 mLs per one dose. So I'm just going to start by writing out some ratios. He's receiving 500 mLs per dose. He's also receiving D10W, which has a ratio of 10 grams to 100 milliliters, just like D5W, this is D10W. I'm also told over here, this is Q4H. This is every 4 hours. That's what this abbreviation means. So that means every 4 hours, this is equivalent to 6 doses in one day. So he's going to have 6 doses in one day. So I'm just kind of summarizing some of the information that I have here. What I'm asking here is how many grams or milligrams of sugar will he be given throughout the entire day? Lots of ways to approach this problem. The first thing I might do is to just figure out if he's receiving 500 milliliters in one dose. Let's figure out how much he's going to receive throughout the whole day. So he'll be receiving 500 mLs in one dose. We know that there are going to be 6 doses in that day. So let's figure out how many mLs that is. This is okay. This is not the only way to start this problem, but it's just kind of my thinking. So 5 times 6, he's going to have, 3,000 milliliters. And let me cross that out. Let me just actually go through and do the cross multiplication. 500 times 6 equal to 1x. X will equal 3,000. So that means he's going to have 3,000 mLs in the day. So that's great. He has 3,000 mLs in one day. Now we can use the drug concentration here, which we're told is D10W. For every 100 mLs, it's going to be 10 grams of sugar. So what I'm going to do now is to see if I can use this 10 grams per ml, or 10 grams per 100 ml, to figure out how many grams of sugar he consumed. So I'm going to do that next. I know, again, that D10W is 10 grams per 100 mLs. So let's figure out how many grams of sugar that is. How many grams of sugar will he be given in a day? Well, he's going to have 3,000 mLs that day. So I'll have 100x equal to 10 times 3,000. Yep, that's right. 100x times or equal to 10 times 3,000. You're going to get x is equal to 300. That means he's going to have 300 grams of sugar. Okay, so we're kind of getting somewhere here. This is 300 grams of sugar in one day. Is that the answer? Is that what we were looking for? How many milligrams of sugar? So we're almost there. We just need to convert this into milligrams. So the last thing I'll do, if you know your metric system, this would be just a simple conversion of moving the decimal point. Or if you don't, you could also set up another proportion. We know the ratio of milligrams to grams is 1,000 milligrams to 1 gram. And what we're looking to do is to figure out how many milligrams are in 300 grams. So this would be the proportion we set up. So we have 300 times 1,000 equal to 1 times x. And you're going to get 300,000. That's a lot of milligrams. Now, like I said, there's a lot of ways to approach this problem. But this was just my thinking. I wanted to first just kind of summarize what I knew, what I was given. That's why I started by writing out my ratios. I know there are 500 milliliters per dose. There are 10 grams per every milliliter. And there are going to be 6 doses given this abbreviation here. So I first just figure out, well, how much total liquid will he be receiving throughout the day, which I found to be 3,000. And if it's going to be 3,000 milliliters of this D10W, that means he's going to have 300 grams. And then I'm going to convert that grams into milligrams. If you're trying to start these problems and jump right from the beginning to the answer, you're going to find that they're quite challenging. So break it down. Write down what you know and see if you can piece together how we might arrive to the answer. The last set of problems is going to be answering some questions here about this chart, relating a chart here talking about breakfast, lunch, and dinner. We know the total calories for each one of the meals and the fat grams for each one of those meals. The first question that is asked of us is what percentage of Tim's total calorie intake was from lunch? So just knowing a little bit about proportions here, I know percent over 100 will equal the part I'm looking for out of the total. I'm looking for the percent, so I know when I set up these two ratios here, I'm not going to know what this percentage is. So immediately I know that that's going to be x over 100. What are these parts in this case and the total in this case? Well, we're talking about calorie intake. So what I'm going to do is to sum the total calories here. So I'm going to grab my calculator, add those up to see what I get. I got 1,023 calories. So that's the total amount of calories. And I want to know what percent is made up of lunch. So if I look at lunch, I see that's 308. So this is the proportion that I have set up. So I'm going to cross multiply to solve here for x. And I'm going to get x is going to be approximately, let's put this in our calculator. I got approximately 30.1. So 30.1% of the calories were from lunch. So I'm just going to summarize. Okay, so now let's move on to the next problem. The nurse forgot to include 500 mLs of D5W that Tim consumed. We're told that each gram of sugar contains approximately 4 calories. How does this affect Tim's total calorie intake? A lot going on here. So what I'm going to do is just start to write out some things that I know. I know he's going to be consuming 500 mLs of D5W. I know D5W has a ratio, in this case, of 5 grams of sugar for every 100 mLs, just summarizing some of the information. I'm also told, given this information, that 1 gram of sugar has 4 calories. So what we're looking for, essentially, if we go back to the problem here, I'm looking first for how does his calorie intake change? So it sounds like I'm looking for how many calories are in this D5W. So how many calories are in this 500 mLs of D5W? So I know he had 500 mLs. I know how much, I could figure out how much sugar is in it. And then if I know how much sugar is in it, I can figure out how many calories. So I'm trying to map out what I'm going to do. So what I'm first going to do here is just to figure out how many mLs, if I know he had 500 mLs, how many grams of sugar is that? So setting up this proportion here, I know there are 5 grams for every 100 mLs, and he had 500 mLs. How many grams is that? Now, if you were to cross multiply here, you're going to get 25. So I'm going to save some time. This would be 25 grams of sugar. So that's how much sugar he had. Great. Now, how much calories, or how many calories are in that? So if I look up here, I'm told that there are 4 calories in every 1 gram. So I'll start there. 4 calories in every 1 gram. And I know in this example that he consumed 25 grams of sugar. I don't know how many calories that is. So here I have my proportion. I'm going to cross multiply. You're going to get 100 equal to x. So that means just by having this extra D5W, that's an extra 100 calories. Is that the answer to the question? Well, let's look up above. How does this affect Tim's calorie intake? Yes, it looks like he had an increase of 100 calories. By consuming the 500 milliliters of D5W, he had an additional 100 calories. The second part is, how does the percentage calculated above change? How does this affect or change this percentage up above? Well, let's look at the pieces that we have here. If we looked up above here, we had x over 100, and we were comparing that to the number of calories at lunch, which, if he had this D5W, that's not going to affect that, right? That's not going to affect the 308. He still had 308 calories at lunch. But with this D5W, this total did change. The total is no longer 100 or 1,023 calories, but it's an additional 100 calories more, right? He consumed this D5W, so now this is 1,123. I'm going to add 100 to that. Now let's figure out what happened to this percentage. So we'll cross multiply. Oop, that should be 100. My apologies. So this will be approximately, when we put this into our calculator, I got approximately 27.4, which is 27.4%. It decreased. So lunch, in this case, the calories from lunch weren't as influential compared to the total, relative to the total calories, knowing once we included this D5W. So since there's a lot of information here, it might be helpful just to kind of start out by writing down some ratios or things that you know. We knew that he consumed 500 mLs of D5W. We know the concentration of D5W. We know how many calories or per gram of sugar there are. And so through these steps of proportions here, setting up these proportions, I'm able to solve for values of x until I get my final solutions.